To start with our introduction to atomic structure and quantum mechanics today, I'm going to introduce to you the first element on the periodic table, which is hydrogen. The H represents the element hydrogen, and we refer to this particular isotope of hydrogen as Hydrogen-1 because its mass number is 1. The 1 here represents the Z value, which is equal to the atomic number, which is equal to the number of protons, which are positively charged, which equals the number of electrons, which are negatively charged, which in this case is 1. So in a neutral atom, the number of positive charges should equal the number of negative charges. The 1 in the upper left-hand corner is what we affectionately refer to as the A value, which is also known as the mass number, which is the sum of the protons plus the number of a different subatomic particles, which are the neutrons, which have a neutral charge. We've already established that this particular isotope has an atomic number of 1, so we say it has 1 proton. And to determine the number of neutrons, if you subtract the Z value, which is the atomic number, from the A value, which is the mass number, that will tell you how many neutrons there are that make up the nucleus. So we would say there's 1 proton and 0 neutrons that comprise the nucleus. Thus, the mass number is 1. This particular isotope of hydrogen, since it has just 1 proton, is referred to as protium. And it's the most abundant isotope in nature. There are approximately 99% of all the isotopes of hydrogen are protium isotopes. We also affectionately say that hydrogen is strategically positioned in row 1, which is also known as period 1 of the periodic table. We say that it's strategically positioned in group 1A, which is also known as column 1. There are 18 columns on the periodic table. So it's in column 1 very strategically, which we'll explain in a moment. And we would also say that it is positioned above the alkali metal group. But it is not an alkali metal, but it's positioned above the alkali metal family. The alkali metal family would be hydrogen, lithium, sodium, potassium, rubidium, cesium, and francium. So that being said, that's our introduction. I always like you to draw what I refer to as the AELD, or the atomic energy level diagram. And that diagram is drawn according to the Bohr's theory of the atom, which is also the solar system model, which analogizes the atom to the solar system in that the nucleus is viewed as being the center of the atom, just like the sun is viewed as being the center of the solar system, and the electrons that orbit the atom are analogized to planets that orbit the sun. That being said, to develop the AELD, what I want you to do is simply to draw a box to represent the particles that make up the nucleus. Divide the box in 2. The top box represents the number of protons, the bottom box represents the number of neutrons, and in this particular isotope there's 1 proton and there's 0 neutrons, and we visualize its lone electron as orbiting the nucleus on a discrete energy level. that discrete energy level is what we refer to as the n=1 energy level, which historically is known as the K shell. There are a couple of ways to view the atom. One is two-dimensionally. Thus, in that view, according to Bohr's theory, Niels Bohr, which developed the solar system model of the atom, Bohr visualized the nucleus of the atom once again as being the center of the atom, like the sun is the center of the solar system. And it's orbited by electrons, which have just enough energy to exist on a discrete orbital on the first energy level. That's one view of the atom. The other thing that I would like you to note is that I'd like you to draw the electron dot representation for hydrogen, and simply the electron dot representation. You include the symbol for the atom as well as the number of electrons. I'm lying to you here a little bit. The number of electrons on the highest occupied energy level, which is 1, and you represent the electron with a dot. This has a lot to do, or has everything to do, with why hydrogen is positioned in group 1 or column 1 of the periodic table, because it's got 1 valence electron. And all the elements in column 1, hydrogen, lithium, sodium, potassium, rubidium, cesium, and francium, all have that one characteristic in common, is that they have 1 valence electron. So moving forward, the other diagram that I ask you to represent is orbital notation. And orbital notation is a way of accounting for the electrons in an atom. And we draw orbital notation by representing it in such a fashion so that the y-axis represents increasing energy away from the nucleus. To start this, we would say that this is the n=1 first energy level. And according to quantum mechanics, the first energy level has just an S sublevel that we refer to as the 1s sublevel. You can think of this circle in which the electron is orbiting as a three-dimensional sphere that contains 1 electron, and we're going to represent that electron with an up arrow. Okay? So the way to read this would be to say that there's 1 electron in an S sublevel on the first energy level, which may be totally confusing to you now, but in a while you'll better understand that. The way to express this is what we refer to as electron configuration. An electron configuration is basically the address of this electron in an atom. And so we would describe this by saying that there's 1 electron in an S sublevel on the first energy level, and we'd simply write the electron configuration for hydrogen as 1s1. Or again, that there's 1 electron in a spherical sublevel on the first energy level. All the elements in column 1 have 1 electron in their highest occupied S sublevel. That's something you may want to look at and you'll become familiarized with. Another little diagram that I ask you to represent is the Cartesian coordinate system. And if you should be relatively familiar with the Cartesian coordinate system, because that is your XY plane. So in other words, you're going to examine the position of that electron in terms of an XY plane. The center of this can be visualized as the nucleus, around which there is one electron that orbits in a discrete energy level. So as you fill out your Meet the Elements lab, you're going to be placing all these various pieces of information on your Meet the Elements lab. For now, that's what I want you to know about hydrogen. And then we'll move on to helium, the next element on the periodic table.